All right. So, no questions? All right. So you may remember then we were doing 10.5. What was it about, this section 10.5? Any idea? No? No ideas? Okay. We're talking about basically lines. This section is about lines and planes in space, in the three-dimensional space. I will now summarize a little bit the most important thing you need to know here. How to find the equation of a line. What do we need to find the equation of a line if we are in 3 dimensions? We need 2 things. Do you remember what they are? We need the vector, yes. So you basically, you have a line. You want to find its equation. You need to find the direction vector of this line. So vector A in the same direction as the line. So you need the vector A, which we will say is A1, A2, A3. So we need this vector. What else do we need? We need the point. Yeah, we need the point. We need one other point. We need the point on the line. Any point. So you need a point P on the line. So a point P with coordinates x1, y1, z1. Then what will be the equation of this line in this case? Do you remember? So once I have the vector and I have the point, I can write the equation of the line in the parametric equations. What are they? X minus x1 equal to a1 t. Yes, where t is the parameter. Then you will have y minus y1 equal a2 t, and z minus z1 equal to a3 t, and these are the equation of the line. Very important. So you need to have a vector in the direction of the line, and you need to have a point on this line. Once you have these 2 things, then you can write the equation of the line. That's the first really, really important test. All the questions, or many of the questions, will be like this. Find the equation of a line. We will not always give you the vector. We will not always give you the point. So maybe first step, find the vector, or maybe find the point. Once you have these 2 things, you can write the equation of the line. Now, the other thing we did was look at the equation of a plane. Now, what do we need to write the equation of a plane? So you have a plane like this in 3 dimensions, and I want to write its equation. Again, how many things do we need? 2 things, yeah? What are they? Very good. Yes, we need a vector perpendicular to the plane. Or we used another word for perpendicular. Do you remember? Normal. A vector normal to the plane. So you need the vector A normal to the plane. That means it's making an angle of 90 degrees with all the points in the plane. So you need a vector, a normal vector. A normal vector or perpendicular. Okay. What else do we need? A point. Yes, we need a point P also on the plane. So I need the point P, which is, again, if I call it x1, y1, z1, then with these 2 things, so let's say A is A1, A2, A3, like this. Then with these 2 things, I should be able to write the equation of the plane. Do you remember what it was?
0 equal A.
Okay, let's put the 0 on the other side. Yeah. No, I don't know why they did it in the book 0 equals something. So let's put that 0 on the other side. So it will be A1. Come on, girls. We did this, yeah? A1 multiplied by x minus x1 plus. So what I'm writing here is the equation of the plane. So A1 x minus x1 plus A2 y. By the way, can I ask you please to write some notes? Just get your paper, whatever you need to be writing. I'm not asking you to write everything, but please, I need to see you writing something. I think that's the way you learn. That's the way you, by actually writing things. You don't have to write everything, but maybe, for example, equation of a line, write these equations. Equation of a plane, same thing. So here, plus A3 Z minus Z1 equal to 0, and that is the equation of the plane when you have its normal vector and you have a point on the plane, then we can write the equation of the plane in this form. That's basically things we talked about before. We did some examples. In a moment, we will come back to this. These are extremely important. What you see here in this whiteboard is extremely important. So, all right. So that's just a little bit of a review of what we did so far. Yeah. Now, okay, I want to come back now to where we stopped last time. We did various things. Yeah, we did all of this. So let me just. Okay, now drawing some simple planes. Later, when we will do integration, you will have to draw some simple shapes in 3 dimensions. So you need to know how to draw some shapes in space. Now, I want to draw the plane y equal to 3. Where is this plane? How? Perhaps before I do that, in the plane, if I say draw, if you want to draw y equal to 3, what is this shape, y equal 3? In the plane, not just x, y. Where are the points with equation y equal to 3? It's a horizontal line, yeah? It's a line. It's a horizontal line which goes through this point 3 here. So this is y equal to 3. That means you take any point on this line, it's always going to be x. The coordinate will be x, could be 1, 2, 3, but y is always 3. So every point on this red line will be of the form x3. So basically, its equation is y equal to 3. So in space, in the plane, y equal 3 is a line. Yeah, it's a line. Horizontal, which means parallel to the x-axis. Parallel to the x-axis. If I say draw the line x equal minus 2, for example, This will be a vertical line. Yeah, it will be a vertical line. It will be here, yes, at -2. So this line is the line x equal -2. Again, it will be parallel this time to what? To the y-axis. Yeah, it will be parallel to the y-axis. So in the plane, just xy, these equations are lines. Well, in space, y equal 3 is not a line. What is it? It's a plane. It's going to be a plane, basically. And it will be, so let me try. It's not always easy to graph in 3 dimensions. I think it's graphed here, actually. But, yeah. Let me, so x, y, z. I want to graph y equal 3. So what I do is I go to 1, 2, 3. And at that point, I will draw a plane which is a bit like this. And this plane goes through the point y equal to 3. This plane is parallel to which plane, by the way? It's parallel to which plane? XZ. Yes, it will be parallel to this plane XZ. Yeah, this is the plane XZ. These two planes will be parallel to each other. So a bit like y equal 3 is parallel to the x-axis. Here, y equal 3 is parallel to the plane XZ. How about y equal 8? It's the same thing, but at the point y equal 8 here, same thing, it will be a plane like this. Also parallel to the others, yeah, like that. So this, basically, same thing, if I want, for example, z equal 2, I will go to z equal 2 and draw a plane parallel to xy. Yes, it will be like a horizontal plane parallel to the xy plane. So that will be the equations y equal a constant or z equal a constant. X equal 2, for example, will be exactly the same. X equal 2 will be parallel to which plane? Y, z. Yeah, x equal 2 will be parallel to like that. So here you can see these planes, one in pink there and one in blue. That's basically. So it's important to know this. Now, example 5.8, finding the intersection of two planes. Again, if you think in space, in the plane xy, when you take two lines, they could be parallel or they could intersect, yeah? If they intersect, they will intersect at one point, yeah? 1 point. Two lines in the plane, when you draw them, they are either parallel, which means they will never intersect, or maybe they will intersect at 1 point. Well, in space, if you take two planes, imagine two planes, like this is a plane, yeah? This wall is a plane. This floor is a plane. Can you see their intersection? What is their intersection? It's a line, yes, it's a line. The intersection of two planes is going to be a line. Yeah, it's a line. Unless they are, of course, unless they are parallel. If you take the ceiling and this floor, will they ever meet? If you extend them, they are parallel, yeah? They are actually parallel, they will never meet. But if two planes meet, they will meet along a line. Their intersection will be a line. So now, of course, a line in space has an equation. and I want now to show you how to get the equation of a line, which is the intersection of two planes. So find the line, which is the intersection of these two planes. So let me show you a little bit how to solve this. Please stop me if there's anything you don't understand. You should always kind of make an effort to stop and ask. Okay. All right, so let me write the two equations. Yeah. Basically, if you want the intersection, you need to consider the two equations together. Yeah. This is what you do, for example, for lines. If you have two lines, you want the intersection point, you need to solve the two equations together to find x and y, like that. Same thing here. So let's consider the two equations together, plus z equal to 3 and x minus 4y plus 3z equal to 5. So I have these two equations which I need to solve together. So the way we do that is, let me subtract. Let me put minus. So first one minus the second one. What will we get on the left side? The x will cancel, yes? How many y's are we going to get? 6y, yeah? 6y minus 2z equal to minus 2, yes? I can get that. And from here, I can get this value of z as a function of y. I can get the z. Now, can you, what is z? Yes. So basically what we'll do, you can, to find z, the easiest way is to take the minus 2z to the other side, take minus 2 here, and then divide both sides by 2. So z will be 3y, yeah, plus 1. Very good. Okay. So z is going to be 3y plus 1. So now I will now write the equations. Remember, equation of a line is a parametric equation. X equals something, y equals something, z equals something in terms of a parameter. So what we're going to do now is, let me use the parameter y as t. If y is t, then z will be what? 3t plus 1. So that's, what is missing now? X. Yeah. X is missing, so we're going to substitute maybe in the first equation. It's okay. I substitute in the first equation, so I will get x plus 2 times t, good, yeah, plus 3t plus 1 equal to 3. So from here, I can get x nicely without any problems. So x will be what? Negative 5t plus 2, sir? Plus 2. Yeah, plus 2. That's it. So, sorry, I need to rewrite this maybe. So, negative 5t plus 2, and that's it. Okay, so we then find our equation of the line. Yeah, the equation of the line is, I can rewrite them if I want. So equation of the intersection line, of the line. I can write it if I want now, starting with x, the usual thing. So x will be minus 5t plus 2, y will be t and z will be 3t plus 1, like this. So suppose I want to find one point on this line. How can I do? Let's say I ask you, give me a point on this line. What can you do? Yeah. Here is a line. Yeah. Here is its equation. Yes, take t equal anything. T equals 0, 1, 2. Every t will give you a point. Yeah, that's what parametric equations really are. Every t will give us a point on the line. So for example, if you take t equals 0, yeah, so if I take, for example, t equal to 0, I get the point. What point I'm getting then? 2, 0, 1. So now, this point, remember, is in the line of intersection. So I can check that this point is in this plane and it's also in this plane. So try to substitute. What is x? 2, 0, 1. 2 plus 1, 3. This point is in the first plane. Let's try. This point, is it in the second plane? It should be, yeah, because it's the intersection line. So x is 2, y is 0, z is 1, 2 plus 3 times 1, 5, and we're okay. So you can check any t you take, you will get a point. You can check that that point is both in this plane and that plane. If it's not, then your answer is not the correct answer. Does that make sense? Yes? Okay. So that's how you find the intersection of two planes if you have their equation. Solve, find maybe z, find x in terms of another variable. Here I did it with z. Maybe you can do it with other. It's not necessarily always z. Yeah. Okay, great. So that's basically that. Now, you may remember we talked about the distance from a point to a line, yeah? You remember that rule? It's an important rule. You should always memorize it. The distance from a point to a line, there is a rule. Do you remember the rule? No. Yeah, if you have a point P and you have a line which goes through 2 points, yeah, Q perhaps, I think we used Q and PR, you want the distance from Q to the line L, like this. There is a rule, yeah? The magnitude of the cross product of PQ and PR, divide this by the magnitude of PR. This is how you get the distance from a point to a line. Now, we have a similar rule for the distance from a point to, not a line this time, but a plane, yes. So here, what you have is a plane, P, and we know its equation. Its equation is given. And I have a point P0 somewhere with its coordinates. Then I want to find the distance from P0 to the plane. So I want to find this D here. That's what I'm looking for. From a point P0 to a plane, the distance. Well, the distance rule is here, like that. So it's the absolute value of, you can see that what you have here is the equation of the plane, but x, y, and z are replaced by the coordinates of the point P0. And then you divide that by the square root of a squared plus b squared plus c squared, like this. So let's just take a simple example. Suppose I have a point P0, which is minus 1, 2, 5, and I want to find the distance from P0 to this plane. Yeah, 3x minus 2y plus 5z equal to 10. What is the distance from P0 to this plane? Okay, so let's use the rule. It's really not difficult at all. So can you, so what will be the
Doctor, do you have to divide them by 10? Or
by
10 should be equal 0.
good question, good question. You can see that the equation here has a d and a 0. So how do you turn this into this? Just bring the 10 to the other side, huh? And it becomes what? Minus 10. That's it. You don't divide, yeah? Don't divide. Because what you want is a 0. So, yes, good question though, yes. So here, what we are going to do then is 3 times what? Not negative, sorry, what? I made a mistake here. So this is an x, yes? Okay, so this is x. Yeah, so 3 times negative 1 minus 2 times 2 plus 5. Oh, why did I put y? Okay. This is z. So. Okay. Right. So plus 5 times 5 minus 10. Very careful. Please be very careful here. And then you need to take the absolute value of that over the square root of 3 squared, yeah, plus minus 2 squared plus 5 squared. And then you just use your calculator to do these calculations. They're not that difficult. And I think I'm getting 8 over square root of 38. So 1 point something, huh? 1.29, huh? Okay, great. So if we want 2 decimal places, 1.29. If we want 1 decimal place, 1.3. Depending. Are we okay with this? So, what is this rule then? What are we finding here? The distance from a point to a plane. Yeah, you have a plane. Doesn't matter where it is, what shape. You have a plane. You have a point. You want the distance from this point to this plane. Well, that's exactly what you do. As long as you have the equation of the plane and the coordinates of the point, then you can find the distance very easily. No issues at all. Okay, now we have now, of course, sometimes you have to do a little bit of work, of course, before you can get, before you can apply a formula. Here we have the, we need to find the distance between 2 parallel planes. So you have 2 planes, yeah, which are parallel. So one is here, and another one is here, yeah, and they are parallel, and I want to find the distance from this one to this one. So I want to find this D here. So what do you think we can do here? Yes, so we need to find a point in the first, let's say this is the P1, plane P1. This is the plane P2. So find the point in the first plane and then use the rule that we just did, that we just used before to find the distance D. So there are two steps here. First step is, let's find a point on P1. Yeah. First, choose a point in P1. Any point, it doesn't matter, because the distance is always going to be the same. Your point here, the distance is here. These distances are all exactly the same. So it doesn't matter where you take your point, yeah? Now, how do I choose a point on a plane? Suppose I say, yeah, here is a line, here is its equation. Give me a point on this line. Find the point which is on this line. How do you do that? Substitute what? A point means the coordinates, yeah? I need two coordinates. I need X, I need Y, yeah, to find the point. So how do I find the point on a line if I have the equation of a line? Come on, girls, you know that. Choose a value of X, yes? Choose X. Do you remember the table? Choose X, find Y. For example, if X is 0, Y will be 1. Here is 1 point, 0, 1. X is 3, Y will be 10. This is another point, 3, 10. So I can find millions of points by choosing X and finding Y. Yeah, like this. So just choose some coordinate, choose one coordinate, find the other coordinate. That will give you any points, all the points you like. Well, we'll do the same here. So now, how do I find the point on this plane? I know the equation of the plane. 2x minus 3y plus z is equal to 6. So what do I need to choose here? You remember before I chose x, I found y, yeah? Here. What do I need to do? Any suggestions? No. No, what I want is, this is a very simple question, girls. I have the equation of the plane, and I want to find one point on this plane. How do I do that? Good. We cannot choose one variable, yeah? So how many variables are we going to choose?
3.
You cannot choose 3. I mean, if I take x equal 1, y equal 2, z equal 4, is this going to be 6? No. So what do I need? How many variables do I need to choose? 2, yes. I need to choose x and y and then find z so that the equation is satisfied. It's like this. With 2 variables, you choose x, you find y. This equation has 3 variables. So you need to choose 2 variables and find the last one so that the equation is satisfied. So really, that's how you find points on this plane. So I could choose x equal, the easiest choice would be to say, let me take x equals 0, let me take y equals 0. Then what will be the value of z? 6. That's it. This is a point on the plane. or no?
Yes.
This point, can you check that it's actually on the plane? Substitute, you will get 6. Suppose I take x equal 1, y equal 1, for example. Okay, let's say I take 1, 1, or even 1 minus 1. What do you think the z will be? 1, exactly 1, yes. Who said 1? Yes, it's 1, because you substitute, yeah? You substitute, you will get 2 plus 3 plus z equal to 6. So z will be equal to, well, that's another point, etc. So you can find millions and millions of points just by choosing x and y. I could even choose x and z and find y. That's also fine. It just depends on how the equation is. So, okay, well, let's just use this point. And now I need to find the distance from this point, 0, 0, 6, to which plane, P1 or P2?
They are parallel.
Yes. So I have now a point here, yeah, which is 0, 0, 6. Now I need to find the distance from this point 0, 0, 6 to the plane P2. Yeah. So now I need to find the distance from 0, 0, 6 to the other plane. Do you understand what I'm saying? You have a point P, you have a point in P1. So now in the plane P1. Now you need to find the distance from that point to the other plane, which is P2. So you have to be a bit careful here. Okay, now I know how to find this distance. So what will be the distance now? We will use the rule, yes. The distance then will be absolute value of 4 times what? 0, yeah? 4 times 0 minus 6 times 0 plus 2 times 6, yeah? And then minus 8 over square root of 4 squared plus minus 6 squared plus 2 squared, like this. I hope you all understood what we did here, yes? And the answer is, the numerator is basically 4, the denominator is square root of 56, and that should give you a little bit more than 0.5. 0.54, yes. 0.54. Or centimeters or whatever the units are. So now, if you had this question of finding the distance between 2 parallel planes, will you do it? Yes? So how many steps do you need to do? 2 steps, yeah? First, you find a point on one plane. It doesn't matter, by the way. You can find it in the second plane if you want. And then you take that point and the other plane and use the rule for the distance between the point and the plane. Okay, great. Any question at all regarding this? So, and the way you choose the point in the plane is just you need to choose 2 variables and find the other variable by substituting. Here I didn't write all the details, but you should, I hope you remember that. Yeah. We choose x and y, we chose them, yes? These 2 things, we choose these values. What happened to the 6? We find it by substitution. Like that. Okay. Okay, now I want to practice a little bit some of these ideas. Parametric equation of this line through the point 1, 2, minus 3 and parallel to this vector. So can you try it, please? Can you try this? So you want to write the parametric equations. Forget the symmetric, no problem. I want to write the parametric equations of a line through this point in the direction of the vector 2, minus 1. So can you write the answer?
I don't remember.
Sorry?
I don't remember it. Is it x minus x1?
Yes, this is what this is. Remember, I kind of reviewed this with you. Yeah, it's here. It's these equations. Yeah, it's like this. Yeah. X minus x1 equal a1t. X minus y minus y1 is a2 times t. Like that. So x minus 1 equal to 2t. And then y minus 2 equal to minus t, yes? And z plus 3 equal to 40, like this. And if you want to find a point on this line, then what do you do? If you want, let's say I want 1 point on this line. Choose t, yes. You need to choose a value of t, yes? T equal 1, 2, 3, etc. And it will give you a point, yeah? For example, if I decide to take t equal 1, for example, it's okay. Then I get x equal 3, yeah? Y will be 1, and z equal 1. So I'm getting the point 3, 1, 1 is a point on this line, yeah? So every t will give you 1 point. So you can find 2 points, you can find 3 points, whatever. So that's basically the way you find the equation here, no problem. So remember, in general, to write the equation of a line in space, you need the 2 things. I repeat, you need 2 things. What are they? A point and a vector in the direction of that line. Yeah. So in 3, for example, in this question 3, we have a line through 2 points. The point 2, 1, 3, and then another point 4, 0, 4. So what is missing here? The vector. Yes. We have 2 points. It's okay. So we have a point. So now we need to find the vector. How do I find the vector? Yes. Yeah. This is like, here is our vector A. So you need to write A. and then once you have the vector A, you can write the equation. What is A then? Yeah, 4 minus 2, it's a minus, yeah? You do so it will be 2 minus 1, 1, very good. Okay. Now we can write the equations, no problem. Which point are we going to use? Doesn't matter. You can use this one, you can use that one. The equations will be exactly the same. So you could use this one, so it will be x minus 2 equal to 2t, y minus 1 equal to minus t, and then z, yeah, minus 3 is equal to t, like this. And because we chose this point, by the way, because we chose 2, 1, 3, if you put in the equation t equals 0, if you put t equals 0 there, you will get exactly that point you used. Yeah, you can see x equals t, y will be 1, x equals 2, y will be 1, and z will be 3. Yeah.
Is it the same for every equation?
Sorry?
For any equation?
Any equation like this, yes. If you are using the point, yeah, here, for example, what was the point? 1, 2, minus 3, yes? Now choose t equals 0 here. What will you get? X equal, y equal, z equal? Yeah, exactly this one. Can you see that? Yeah. And this vector, 2 minus 1, 4, you can see it here in the coefficients of t. 2 minus 1, 4. Yeah? Here, 2 minus 1, 4. Here, the vector, 2 minus 1, 1. 2 minus 1, 1. And the point itself, 2, 1, 3 is here. Okay, now, this time we have a point, 1, 2, 1, and this line is parallel to this one. So, our line, L, yeah, is parallel to this line, x equal to 2 minus 3. What is missing here, by the way? If I want the equation of this line, so 1, 2, 1, the point is there. What is missing? The vector, yeah? The vector is missing, but because the lines are parallel, that means they will have the same vector direction. Now this A, can I get it? From the equations of this line, what is the vector A? Minus 3, 0, and 1. Yes. So A is actually minus 3, 0, and 1. So now you have the point and you have the vector. Do you understand this or no? No. Okay, let me just... So basically what you have here is 2 lines, yeah? 2 lines. This one goes through a certain point, yeah? Let me just go check the values. 1, 2, 1. And I want to find the equation of this line. What is the equation of this line? I have a point. I don't have the vector A. I don't have it. But I know something about this line. What do I know? this line is parallel to the other line, which has the following equation: x equal to 2 minus 3t, y equal 4, and z equal 6 plus t. From this equation, I can get the vector. Because they are parallel, then they have the same direction vector. Because they are parallel, so this A will be the same as the A for the other line, because they are parallel. Now, what is A for this line? From this equation, you can get the A. Yeah, when you have an equation like this, what is the vector A? It's the coefficient of t. Yeah, look at t. What do you have? You have a minus 3t. Then you have no t, so that means it's a 0. And z with 1, so you get 1 there. So that is the vector. And this A, you can use it also for the other, because they are parallel. So they are exactly the same vectors. Do you understand it? Yeah. So I use the second line to get the vector A, and I take that A and use it for the line. Sorry?
I thought you substitute the point and then
No, it's just the vector A comes from the equation. Are you okay with this? Yeah. So, let me go back a little bit then. So basically that's what we are saying. Now we have, so use the second line to get the vector A. Use that A for L, which is our line here. And now we have A and we have the point. So we can write the equation. So what will be the equation then, girls? X minus 1 equal to minus 3t. Y minus 2 equal to 0 times t, so 0. And z minus 1 equal to 2t, like this, and that's it. So we have the equation of our line. From the point and from the fact that it's parallel to another line from which I can get the vector direction A, and that's it. Okay, now here we have the line through 2, 0, 1, perpendicular to two other vectors. So I have a vector u, I have a vector v, so we have two vectors, u, v. And what I know now about the line is that it's perpendicular to these two vectors. It makes an angle of 90 degrees with u and with the vector v, like that. And it goes through the point 2, 0, 1. Now, what is missing here again? We have a point, yes? So what is missing is a vector in the direction of the line. So we need to find a vector A on this line. How can we get the vector A? The cross product, yes. The cross product. If I take U cross product with V, I will get a vector in the direction of the line. Exactly in the direction of, because the line is perpendicular to U and V. So A, in this case, will just be U cross V. That will give us exactly a vector which we can use on the line. So let me do this. So I, J, K, and then U is 1, 0, 2, and the vector, okay, 1, 0, 2, and the vector V is 0, 2, 1. So what is this vector A then? So let's see if we can find it directly. Minus 4I, yes? So minus 4, yeah. J. Minus 1, yes, minus 1. Yeah, because remember with J, you need to have a minus, so it's minus 1. And yes, and K is a 2, yes, 2. So that is the vector A in the direction of the line that we want. So we have the line, we have the point, so we have the vector, we have the point, so we can write the equation without too many problems. So equation will be, okay, x minus 2 equal to minus 4 t, so, and then y equal to minus t, and z minus 1 is equal to 2t, and this is the equation of the line, which is perpendicular to these two vectors. So think a little bit. How did we do this? We have a line perpendicular to two vectors. So by taking the cross product of these two vectors, I get a vector exactly in the same direction as the line. So line, vector. Can you see that? Yeah. By taking the cross product of U and V, we get A. Now we have a line, it has a point, the direction vector is given, so finish. I can write its equation without too many problems. Okay, I'll give you 5 minutes, girls, 5 minutes to relax a little bit, and then we will continue this. Any questions before we, anything? No? Okay, so take a 5 minute break.